Welcome back to the channel. Today we're going to talk about taking this simple wedge block and creating this technical drawing. Stick around. It'll be a blast. Let's rock and roll. So we're going to set this wedge block to 1018 steel. So we go physical properties. We scroll down in the steels, yada yada, skip a few, and we get down here to the 1018 series. There's a bunch of different ones. Doesn't really matter which one. For this, I'm just looking for the weight, so I'm just going to drag the 1018 106 HR on. And then we go properties, and we need to jot down this 49.17 mass of this part. We're going to need that on the back side. So now that we got this, let's go ahead and get creating the drawing. So we go drawing from design. I'm going to use my 8.5 by 11 because this is for my high school students and this prints well. For the template, and we go ahead and hit go, and there it comes. So we're going to go ahead and place it. This one I modeled correctly, so the front appears to be the front. We're going to go ahead and place it. We are going to change the scale to 1. So let's stay at half. Plenty of room to put dimensions in, and click OK. We're going to project the top, the right, and the ISO. And we're going to, of course, turn on the ISO for color and hit close. I do have a color printer, so we'll move that a little off, and we'll spread these out. Okay, like always, after I get the model in, I like to finish out the title block and the notes. So we'll start with the title block. This is actually taught in IED. Remember, everything has to be capitalized. Fusion Monday drawing numbers are on the 50 series, and then this is week 17, and then this is the second drawing from week 17. Rev is the year and the first attempt at that year. The weight is that number that we got on the other side, that 49.17 OZ for the ounces, and hit enter. We don't have approved and checked by because we haven't got that far finished. And then we're going to come over here in the material. We are going to write 1018 steel. Now, if I had put in the 106 HR, it's only going to increase the cost of my material. So I'm going to leave that off. And this is going to be black oxide, which is like a black color that you rust the metal to. Looks like screws and bolts, especially Allen head or cap head screws and bolts, come in that black color. So we go ahead and hit close. So now we got to start with the dimensions. Remember, whenever we are making a drawing, the manufacturer wants to know how big this thing is. So they want the basic height, width, and depth so they can kind of get a grasp of what they're making. Is it the size of a pinhead, or is it something that fits in the palm of your hand, or is it a part for an aircraft carrier? So let's get going on the dimensions. So we're going to specify that this has 3 inches wide, so it's a 3 by 3 block, and then it's a 1.5 inches thick. So this is something that sticks in the palm of your hands. Now, the problem here is this default setting in Fusion really gives us no tolerancing. Technically, there's no decimal point, so we can't even really rely on this 1x tolerance of 0.1, which is a huge tolerance. So let's go in and let's show you how you can modify so all of the dimensions will give us what's called the trailing zeros. So if we go into Document Settings and we go down to Display Trailing Zeros, we can click on this, and we want to display trailing zeros right here. And we can do leading zeros too, which we'll put up in front of the decimal. And then what precision do we want the entire thing to be the base dimension? And I would normally say 2 decimal points after the thing. So this should give us like 3.00 when we click OK, which is exactly what we did. So it means our base tolerance is going to be plus or minus 20 thousandths. and we can specify in specific places a tighter tolerance, or we can go in and specify a lesser tolerance where it matters. So now let's talk about we have 3 more dimensions. The first one is the dimension from this side to here. Not that one. My mistake. Oops. Undo. I want to delete this dimension. I did not pick up the right lines from here to here, and we drag it up. And this, remember when we do this, oh no, where'd my, oh, there they go. Just a graphics card error, no big deal. This dimension, by doing it this way, I am specifying I want this groove to be 0.15 plus or minus 20 thousandths. And actually, this is a wedge. We want to make this even a tighter tolerance. So we're going to double click on just this dimension. And we're going to move this tolerance to 3 decimal spots, meaning that distance has to be plus or minus 10 thousandths of an inch. Meaning this space over here, this flat spot, it can be whatever's left after we hit the tight tolerance for the width of the wedge. Okay? The next dimension we're going to talk about is an angle. A lot of students get confused about angles. You can drop down and choose angular dimension like this, but you can also choose on this sun, which is kind of your smart dimension. So if I click on one line and then click on another line, it'll give me the angle between them. So that's now got the angle. Problem is we're not fully dimensioned. And one problem students tend to do, let me drag this angle out for a minute, is they want to go, okay, from here to the top of this angle is 0.3, and from here to the bottom of this angle is 0.3. So the starting point and ending point of the angle is what you're telling me. Well, then I don't need this angle dimension because I don't care what the angle is. I care where it starts and where it ends, which has its applications. If you're using this wedge to precisely lift an object and you want it to lift exactly 0.8 in our situation, then this would matter. If we want it to be at a 15-degree angle, then we got to get rid of one of these. And the problem, the hidden problem here is, if I double click on this and I increase its precision to the top, you will notice it has some unobtainable number here. So we're actually just going to delete this one, and we're going to leave it at a 15-degree angle. Now, I'm also going to show us how, like, if we want this to be a very tight tolerance, even tighter than our plus or minus 10, we can go here and set a symmetric tolerance, and we can say plus or minus 0.01 or 1/10,000th, which I need to drag it out, and I clearly need to increase the precision to get that in there. So now I am saying, that does not look good. There we go. Now I'm saying that this angle needs to start at 0.5 from the bottom plus or minus 1/1000th of an inch, which is extremely tight tolerance. I just took this from being a relatively inexpensive part to produce to a part that's going to cost a good amount of money over this one extremely tight tolerance. Now, any manufacturer would hate you for this as well, because how are they going to measure that? How are they going to prove that this, at the very beginning, starts at that angle? And that is something that is extremely difficult to prove. It can be done. CMM machines can do it. There are ways to use a test indicator to do it, but it's going to be a very, very tough thing to do. We're going to leave it because I'm trying to teach you a lesson. We're not actually making this part. Hopefully you learned something today. Hit like and subscribe, and I'll see you in the next one. Have a great day.